Okay, this video is going to cover lesson 5-7, which is scatter plots and what they call trend lines, or we're going to call it lines of best fit. Okay? All right, so a scatter plot. You're kind of seeing some examples here of scatter plots. Scatter plots is just a graph that relates two different sets of data by displaying them as ordered pairs. Okay? So again, ordered pairs, just coordinate points all over the place, and we've got two different sets of data or two different kind of ideas here that we're graphing. And we're trying to figure out, is there a relationship or not? So we have what's called correlation. And correlation is kind of just a fancy way of saying, is there a relationship? So here, when we see a positive correlation, you'll see we've got a set of data, but they're going up or trending up in a positive manner. So as x's go up or as 1 goes up, the y's go up. Okay? Here, this is called a negative. So if we think about our negative sloped lines, right? It's going downhill. This is going uphill. So downhill. So what happens is as x continues to increase and get bigger and bigger and bigger, my y values start coming down. Okay, so as one thing goes up, the other one comes down. And then we have what's called no correlation, which simply means there is no relationship at all. It's just crazy hodgepodge stuff all over the place. Okay, example 1 here says determine the correlation of each situation and explain. Okay, so the amount of time you study for a test and the score you receive. So what you're thinking of is, are both of them going up? Is one going up, one going down? Or is there no relationship here at all? Well, hopefully, in this case, as you can study, the more time you're putting in for your test, hopefully we're going to see your test score go up. All right, so in this case, this is going to be a positive correlation. And the more time you study, the higher your test score. Now, we know that that's not necessarily always true, but there is a strong relationship there. The more we study, the higher our test scores go. All right, so the next one here. The height of a person and the letters in a person's name. So what kind of relationship would those have? How tall someone is and how many letters are in their name. Well, hopefully you're saying there is no relationship there. A height of a person has nothing to do with their name. So in this case, there would be no correlation. And if there's no correlation, there's nothing to write about. We don't have to worry about talking about a relationship because there is no relationship. Remember, correlation is a fancy word meaning relationship. All right, and C, the price of a hamburger at a grocery store and the amount of hamburgers sold. So let's think about that for a second. If a hamburger goes on sale, what normally happens to the hamburger? Well, people come in and buy it up real quick because it's really cheap. So when something is cheap, we have a tendency to buy a lot of it, okay? Now, if hamburger prices were to skyrocket, then we kind of see demand go down. Hamburgers are really expensive. We have a tendency not to buy as much. So in this case, as one thing is going up, the other one's coming down. So this is going to be a negative correlation. Okay, negative correlation. The cheaper the hamburger, the more people buy. Okay. All right, and the next thing we have to look at here is called line of best fit. Okay, so here in a minute, we're going to actually take a look at how to make a scatter plot, and then we're going to be coming up with a line that best represents the data kind of overall. Okay, so a line on a scatter plot, it's drawn near points, but actually we're going to make sure ours goes through at least 2 points, and it's going to show that there's a relationship or correlation. Okay, all right, so if we go to the first example here. The table shows the altitude of an airplane and the temperature outside the plane. Okay, so first thing we're going to have to do is we're going to graph. Now the nice thing here is we've already got numbers and we've already got the labels on there for us, so that's fabulous. So all we're having to do is graph here. Now please watch here. This does say in hundreds, okay? So starting off though, I'm at 0 and 59. So I'm going to go ahead and do 0 and 59. So we'll put a point there. Okay, our next coordinate point is 559.2. So now 500, again, I'm going to put it on the 5. And then 59.2, well, that's going to be, right about where we're currently at. Our next one is 1,061.3, so that's going to be on my 10. And then I'm going to just estimate where that 61.3 is going to be. 15, and let's see, 55.5. So 55 would be right around here. The next one we have there is 2,041.6. So 41.6 would be right about there. 2,529.8. So really starting to drop off here a little, aren't we? 3,029. So pretty close to where we're at. 35 is 18.1. So right around there. 4,000 is 26. So it actually bumps back up here. Got a little bit of a jump up. And then at 45, we're at 12.4. And then at the 5,000 mark there, we're at 0.6. So, we're like right there. Okay? All right, so there's my points. So now what I'm kind of looking for, is there a relationship here? Because that's the first question. What type of relationship or correlation does the scatter plot show and explain? Well, overall, this is a downward trend. So our correlation here or our relationship would be negative. Okay. All right, and so our reasoning would be the higher the altitude, the lower the temperature. Okay, so as one goes up, one comes down. Okay, so on part C, it says, draw a line of fit, or line of best fit. What 2 points does your line go through? Okay, so we're going to kind of zoom in here a little bit. And this gets a little tricky because you can have different answers than the people around you, all right? So you're going to have something, though, that's going to be downward trending, right? And we need to try to just put it through. It has to go through 2 points because we're going to ask us to write an equation here soon. And so what we're going to do, again, you're just going to kind of do the best you can. I'm probably going to draw mine maybe a little bit more through this direction right here. And it's tricky on these because this does not make a nice straight line. Okay, so now when I'm kind of looking at this, you're kind of looking, okay, I got 1, 2, maybe 3, 4, 5 points here. I've got a couple below, so maybe I should have moved my line a little higher, but we're going to go ahead and stick with it. I'm going to say it's going through this point and this point. Okay, so line of fit. Now, what 2 points does it go through? So mine would be 5,000, or sorry, 500, right? So 500. And 59.2. And then my other one I marked there is 3,029.9. And like I said, this is kind of hard because everybody's going to have something a little different here. All right, so now it says write an equation of the line of best fit in slope-intercept form. So now keeping in mind, right, when we're given 2 coordinate points, first thing we've got to do is find our slope. So I'm going to go ahead and take 29.9 minus 59.2 over 3,000 minus 500. Okay, so we can do a little calculator work here. So 29.9 minus 59.2. So I get negative 29.3. On the bottom, I subtract there and get 2,500. So 29.3 divided by 2,500. And I'm going to get a decimal here of negative 0. I'm going to just round it off to 0.1. It gives me 4 or 5 decimal places. Just give me 2 to 3, whatever you've got there. Just depends on the problem. All right, so now I'm going to pick a point, right? So point slope. I'm just going to pick the first one right here. Okay, so I'm going to start my point slope form. So I'm going to get y minus 59.2 equals negative 0.01 and x minus 500. Okay, so now I'm going to go ahead and distribute. So y minus 59.2 equals negative 0.01x plus, move my two decimals over and I get a 5. And now I'm going to add 59.2 to both sides. So I get y equals negative 0.01x plus 64.2. And that is the equation of my line of fit. Okay, again, everybody could have different answers here. So when I kind of look at this, it says it should start around 64. Well, if we look at my grid right here, 64 would be right there. That's pretty dang close. All right, and we've got a downward sloped line here, so that's looking good there. Okay, so now it's saying use your line of best fit. What is the temperature at 2500? So looking at 2500 here, on my line, I don't know, not quite. I think 35. Let me zoom in here. Okay, again, looking at my line, not the data point, but on my line, about where is this crossing? I don't know. I'm going to say like maybe 34-ish. Okay, so down here, 34 degrees would be my answer. Now, if I were to actually take this and plug it in and go ahead and do that, so negative 0.01 times 2500 plus the 64.2, when I do that, it's saying I should get 39.2. So I am a little bit off there as far as what I'm seeing on my line versus what I'm seeing as an answer, okay? All right, so now using your line of best fit equation, what is the altitude if the temperature is negative 20? All right, well, temperature is negative 20. That means I'm going to plug in negative 20 here and just solve the equation. Okay, so I'm going to go ahead and subtract my 64.2 over. So I get negative 84.2 equals negative 0.01x. And now I'm going to divide by that negative 0.01. Okay, and so when I did that, I ended up with 8420. Okay, so that would be how many feet I'm at to get a temperature of negative 20. And now the reason it asks us to use our equation here is because negative 20 is not anywhere on my grid. Yeah, the temperature can be negative 20, but we don't know where that is on the grid because that's not what they gave us. So we have to use the equation here. We're back on this one. I could kind of look at my blue line and get an estimate, or I could use my equation and get maybe a better estimate since my line was a little off, okay? Definitely going to have some error here, though, just depending on how well you draw your line and what points you pick. Again, everybody could have a different answer here, just depend on what you pick, okay? All right, so what I want you to do is I want you to kind of pause the video and work through this problem on your own and see how you do. Okay, so I've went ahead and I have put my data points in here so you can kind of see. I've got points. I went ahead and drew a line of fit and I've got 2 points picked out. Now, it's okay if you have different points picked out here. Okay, so like I said, this is a little trickier because all our answers could be a little different and still be correct based on what we've got, okay? So first off, what type of correlation? Well, this would be a positive correlation, okay? So you should have positive correlation here. Okay, so the older the panda gets, the more it weighs. Again, as one goes up, the other goes up. Okay, all right, so now it says draw a line of fit. I've already done that. And my 2 points here, I have got 2 and 7.6, and then it was 8 and 37.9. Now again, you will have two different points here, but just make sure you kind of went through the same process I went through. Okay, so first thing we're going to do, since it says slope-intercept, I need to find the slope. So I'm going to kind of start working that over here. So I get 37.9 minus 7.6, and then I've got 8 minus 2. All right, so on top here I've got 30.3, and on the bottom I've got a 6. So I'm going to take 30.3, divide by 6, and end up with 5.05. Okay, so there's my slope. It's positive, and that's a good thing. All right, I'm going to go ahead and just use the first equation, or first coordinate point here. So I have got y minus 7.6 equals 5.05 x minus 2. Okay, so now I'm going to go ahead and solve that. So y minus 7.6 equals 5.05x minus 10.1 or 10. And then I'm going to add that 7.6 over to the other side there. So I get y equals 5.05x, and then negative 10.10 plus 7.6, I'm getting negative 2.5. Okay, now I know something's kind of a little funky here, right? My line's a little off because it's saying my start weight is going to be negative 2.5. Man, I sure hope a panda is not negative weight. That's going to be a little rough. So I know I definitely got some air up here on my line of fit. So my line of fit maybe could have been a little bit better there because there's no way a panda is being born at a negative weight. So now using your line of fit, what would be the weight of the 5-month-old panda? So 5 months, let's see, would cross right about there. So I don't know, maybe 22-ish, just kind of looking at it and ballparking it. Okay, so by looking at my line, I'm going to say right around 22 pounds. Okay, so now let me plug it in, though, and let's see what we get here when we plug that 5 in. So I have y equals 5.05 times 5 minus 2.5. Okay, so when I get that in my calculator, I ended up with 22.75. So pretty dang close there. That's a lot closer than my last one, wasn't it? Okay, so now using your line of fit equation, how old would the panda if it weighs 70 pounds? All right, so we're going to plug in 70, right? We're going to plug that in for the y because that's my y values. So 70 equals 5.05x minus 2.5. So 72.5 equals 5.05. So I just added that 2.5 over. And now I'm going to divide 72.5 divided by the 5.05. And I ended up with 14.4 rounded off. And that would be years. Okay, so let's look here. So, well, that's probably about right. Or months, not years. I need to change that. So at 14 months, that's probably about right, 70 pounds. Okay, so that's not too bad. But let me go ahead and make that correction down here. Let's do months here instead. Okay. All right, and that concludes these notes.